Okay, today we're going to look at Lesson 7. This is the first part of Section 6 in your textbook, and your learning objective is I can solve absolute value equations. Now, you should have done this in Algebra 1. I know that I did it in my class, so most of you should be at least familiar with it, even if you don't remember exactly what to do. For vocab today, we just have absolute value. Absolute value is the distance a number is from 0 on a number line. Okay, and then these are absolute value bars. So I did a little example here. The absolute value of 3 is 3 because it's 3 spaces from 0 on a number line. The absolute value of -3 is also 3 because if you count the spaces on a number line, you get 3. So something important to notice here is that absolute value is never negative. We're measuring distance, so distance isn't negative. Okay, if you take the absolute value of a negative number, then your absolute value is positive. It's a distance. Okay, but it is important to realize that though absolute value is never negative, the solution could be negative. Okay, so if we're talking about the absolute value of x is some number, that's like asking what number or numbers, I'm going to say what number is blank spaces from 0 on a number line. Okay, and so if I plug some number in there, say the absolute value of x equals 6, then I'm asking what number is 6 spaces from 0 on a number line. So in this case, let's think about it. What are two numbers that are 6 spaces away from 0? Well, it would be 6 and -6. So the absolute value itself isn't negative, but the values, the solutions for x could be. Okay, so that's an important thing to realize. Absolute value is not negative, but the solution to the problem or to the equation could be negative. So take just a second, make sure you have these notes written down, this vocabulary written down before we start talking about how to solve absolute value equations. Okay, now write down the steps for solving absolute value equations. Number 1, remove all operations on the outside of the bars, just like a normal equation. So you could see some addition, subtraction, multiplication, or division on the outside of the absolute value bars. And if you do, we're going to get rid of them just by doing the opposite, just like we do solving any other equation. Okay, that's the first step. Second, you're going to remove the bars by making two equations. Now, this is the step that gets skipped the most, but it's the most important. You have to make two equations, just like up here in this little problem that we solved. You had two answers, two solutions, two equations, two equivalent statements. And if you notice, the bars went away. Okay, in order to get the bars off of the equation, you have to make two. All right, you cannot skip that step. Step number 3, simplify if needed. You might have to simplify, you might not, and then solve the remaining equation. Now, if the problem is super simple, like this one up here, you might not have to do anything else. Once you split it apart, you might just have your answer and you can stop. But that doesn't happen every time. Sometimes you have to do a little bit more work to get your final solutions. And we made a note, there's usually two answers. It's very rare that you will stumble upon an absolute value equation that just has one answer, but I'm not saying it's impossible. So for the most part, you should have two answers. You should be circling, boxing, typing in two separate answers. So keep that in mind. Here are our first 3 examples. So we'll look at these together. So number 1, the absolute value of x equals 8. So step 1, remove all of the operations on the outside. There are no operations on the outside of the bars, so we skip. Number 2, remove the bars by making two equations. So we're going to remove the bars, and what's left inside is an x. So we have x equals and x equals. Okay, so there are two equations. Now, one equation has to equal the positive, so that's a positive 8. One has to equal the negative, so the negative of 8 is negative 8. Then step 3, simplify and solve. There's nothing left for me to simplify or solve, so I'm just going to circle or box these. Another way to write this answer would be x equals plus or minus 8. That means you could have the positive of 8 or the negative of 8. Okay, number 2, remove operations on the outside. There's nothing on the outside, so we can skip step 1. Step 2, remove the bars by making two equations. So if we take the bars off, we're left with 2x. So we're going to have 2x and 2x. One equals a positive, one equals a negative. So one is going to equal 10. One is going to equal negative 10. Step 3, simplify and solve. There's nothing left for me to simplify here, but I can solve. So we are multiplying by 2, so I'm going to divide by 2, and I get x equals 5. On the other one, I'll divide by 2 and get x equals negative 5. There are my two solutions. And then number 3 is very, very similar to number 2. So pause the video, give it a try, and see what you get. Okay, there's nothing outside the bar, so let's make our two equations. Negative 3x equals 18. Negative 3x equals negative 18. We're going to divide by negative 3, and we get x equals negative 6. Do the same thing to the other problem, and we get x equals 6. Okay, so those are some pretty basic absolute value equations. You will see some like that in your homework. Now let's take a look at number 4. It's a little bit different. We don't have anything on the outside of the bar, so we're going to start by making two equations. So we're going to have x minus 2 equals 7 and x minus 2 equals negative 7, and then we're going to solve each of these. So on the first one, we're going to add 2 to both sides, and we get x equals 9. On the other one, we're going to add 2, and we get x equals negative 5. So there are your two solutions. And you might notice something a little bit different about these two answers than what we've seen previously. If you flip back and look at examples 1, 2, and 3, our answers were very similar. 8 and negative 8, 5 and negative 5, 6 and negative 6. Okay, that happened on all these, but it didn't on number 4. So what's the difference? The difference is that on number 4, we have addition or subtraction inside the bars. So when you have addition or subtraction on the inside, it's going to make your numbers quite different for your answers. Okay, so watch for that. Don't just assume you know what the answer is going to be. Make sure you actually work through the math and see what it is. Okay, here's number 5, and it looks a little bit different as well. So we've got the absolute value of 3x, then minus 2 equals 25. So let's think through those steps. Do we have anything on the outside of the bars? Yeah, we do this time. So let's take care of it first. So we have a minus 2. How do we get rid of a minus 2? We add 2. So we have the absolute value of 3x equals 27. Now, there's no other operations on the outside, so we can make two equations. 3x equals 27 and 3x equals negative 27. You're going to divide by 3, and we get x equals 9 and x equals negative 9. Now remember, you can rewrite that as x equals plus or minus 9. Okay, number 6 is a little bit different as well. This time on the inside of the bars, we have a 2-step equation, and then on the outside, we're multiplying by a 4. So it's important to note that here we have a multiplication dot between the 4 and the absolute value bars. So what do we do when we multiply by something? We divide it. So we're going to divide both sides by 4. and we get the absolute value of 2x plus 2 equals 8. Then you don't have anything else on the outside of the bars, so make your two equations. 2x plus 2 equals 8. 2x plus 2 equals negative 8. Solve each of those two-step equations. So subtract 2, and you have 2x equals 6, so x equals 3. The other one, subtract 2, you've got 2x equals negative 10, so x equals negative 5. And again, remember, we have two completely different numbers here because you have addition or subtraction inside the bars. Up here, the subtraction was outside. Here, we have addition inside. Okay, so here is example number 7. The absolute value of 8n plus 3, minus 3. I apologize. Minus 3 plus 6 equals 4. I want you to pause the video, give this a try, and see what you get. Okay, let's check it. First, look at the outside of the bars. We have a plus 6. How do we get rid of it? By subtracting. So if the absolute value of 8n minus 3 equals negative 2, there's nothing else outside the bars, so make two equations. 8n minus 3 equals negative 2. Oh, wait a minute. What do you notice? I shouldn't have even gotten this far, because what do we have here? The absolute value of this equals negative 2. Are we allowed to have an absolute value that's negative? No, we're not. So what do you think we would write down? What happens when you are solving an equation and you get something that cannot work? It cannot be true. That's right. We put no solution. So on number 7, put no solution. Okay, here's example number 8. I want you to pause the video, give that a try, see what you can do. All right, let's check your answers. So look on the outside of the bars. We have 6 times this quantity and a minus 3. Which one of those do I need to get rid of first? Good, minus 3. So we're going to add 3 to both sides. We have 6 times the absolute value of 5y minus 5 equals 18. Now we're multiplying by 6. How do we get rid of it? Using division. The absolute value of 5y minus 5 equals 3. Now make two equations. 5y minus 5 equals 3. 5y minus 5 equals negative 3. Solve those two-step equations. So add 5, you get 5y equals 8. And then divide by 5, and you get y equals 8/5. On the other one, we add 5 and get 5y equals 2. Divide by 5, and you get y equals 2/5. So this one's a little bit different because both of our answers are positive and they're both fractions. That's okay. That can happen. Because up here we set our two equations to one positive and one negative, and this is the way it worked out. So that's perfectly fine. Now, if you're in the regular Algebra 2 class, you can stop there unless you just want to have a little challenge. Then you can come over here with me and we're going to do the little honors section. If you're in honors, you need to watch this video and look at these problems because it's going to be helpful to you in the homework. So this is bonus example number 9, and we have the absolute value of x minus 3 equals 6x plus 12. Okay, so here's your absolute value equation. We look outside the bars. There are no operations outside the bars. So we can go straight to making two equations. Now, it's a little bit different because we've got this quantity over here, and it's not just a regular number. We're still going to do the same thing. So x minus 3 equals 6x plus 12. And then we need the negatives of this. So our other one will be x minus 3 equals negative 6x minus 12. So now you have two multi-step equations. Take just a second, solve each of those, and we'll see what we get. Okay, sorry about that. Now, we've got these two answers, but we can't stop there. We have to plug each of those numbers back into the equation and see what we get. So if I start with the first one, we have the absolute value of negative 3 minus 3 equals 6 times the quantity negative 3 plus 12. And so we have negative 3 minus 3, which is negative 6, equals 6 times negative 3 is negative 18 plus 12. So the absolute value of negative 6 is 6. Negative 18 plus 12 is negative 6. Okay, so we know that 6 does not equal negative 6, so that cannot be a solution. Okay, now we'll do the same thing with negative 9/7. So we have the absolute value of negative 9/7 minus 3 equals 6 times the quantity, or not quantity, times negative 9/7 plus 12. Okay, now I was running out of room down here at the bottom, so I just did some simplification on my calculator and then came back. So I did negative 9/7 minus 3 is negative 37 in absolute value bars. The other side, I did 6 times negative 9/7 plus 12, and that gave me 37. And then I came over here, and we see that the absolute value of negative 37 is 37, and that does equal positive 37. This does work. That is true. So this is the solution that we would enter into Math Excel. Okay. Now, I think you have two problems like this on Math Excel, you honors kids. So what you'll need to do is make sure you make your two equations first. So one of them is just this without the bars. The other one, you have to do the opposite of what's on the right side. So like I changed positive 6x to negative and positive 12 to negative. Okay, you solve each of those and you have your two solutions. Plug each of those solutions back into the original problem and see what you get. So like negative 3 did not work for us, but negative 9/7 did work for us. And that's what you would type in Math Excel. Okay, as always, if you need any help, you can hit that Ask My Instructor button, email me, ask me in the Google Meet, whatever you need to do. Have a great day.